Welcome to our discussion about Python strings, string objects in Python. I'm Professor Patrick. I'm in the Paul H. Chook Department of Information Systems and Statistics here at Baruch. I'll be talking about strings today. We'll talk about strings in two parts. So there'll be a second recording after this one. We'll come to a break at the end of this recording, and then you can watch the second recording afterward. In this recording, we'll talk about creating and formatting strings in Python. And then we'll get into some different methods that you can use with strings in the next video. Both videos use the same notebook. You can get there with this shortened link, bit.ly or bit.ly/Python strings. That's bit.ly/Python strings with the P of Python and the S of strings capitalized. Let's jump into that notebook. It's a conglomeration of content from a number of different sources, as you can see at the top, including some from Dr. Chuck, Dr. Charles Severance, and a number of things that I've taught over the years. As I mentioned, the shortened URL to get to this notebook is the bit.ly Python strings. So what are strings? Let's talk about that. They're a text data type. We use strings to store text in variables or objects in Python. And any data type written as text in Python is a string. String is essentially a sequence of characters. You can think of each character in a string as an element in that string. One way that we can create a string is to simply put a character or some characters in quotes. We could use single quotes or double quotes, but we have to be careful that when we open a string with one type of quote, we close it with the same type. So we can open a string with single quotes as long as we close it with single quotes. We could open a string with double quotes as long as we close it with double quotes. It might be helpful to remember that if the string that you intend to create includes something like an apostrophe or perhaps some double quotes around a quotation in the middle of the string, you can always use the alternate character to enclose the string, so that gives you a way to use an apostrophe or a double quote in a string. We'll see another way that we can do that. So if you go through the notebook, you'll see first time through, we'll have to sort of wake up our notebook. It will run through and do a couple of assignments for us. Here we create a variable called letter, and we just assign a one-character string P to that variable. And then we create another variable called greeting, and we assign a string hello world to that variable. Both the string of the character P and that hello world phrase are enclosed in single quotes. We do another assignment later in this code block where we create a variable called sentence, and we use double quotes to enclose a string. And you can see from the print statements in this block of code that we can print those variables, and we get the strings that we assign to them. The other function other than print that we're taking advantage of here is the length function. If we ask for the length of a variable that's a string variable, we get a count of the number of elements in the string, essentially the number of characters in the string. You can play around with the notebook and do your own assignments into a variable here. You can play around with enclosing the entire string in either single or double quotes. But let's talk about a third type of string, a multi-line string. This is a string that can have line returns or new line characters in it. The strings that we looked at earlier were all one line long. If we have multiple lines of text that we'd like to enclose in a string, we make a multi-line string. We begin a multi-line string with 3 quotes, and we close it with 3 quotes, as you can see in this block of code. Right, the multi-line string that starts, I've gone all the way to the bottom of it, that starts, I am a fashion designer, and ends with my own fashion line, that's enclosed in 3 sets of single quotes. Alternatively, we could use 3 sets of double quotes and create a multi-line string as well. And you can see here after the assignments, our print statements, when they print the variables that we created, print the entire text, including the new line characters, including the special characters. We can also take the content of a variable that's of a different type, an integer, a float, and use the string function, which is written str. We pass the string function an argument, it returns a string. And so here we're pulling in from the math module, we'll pull in the value of pi. Don't worry about imports and pull this from statement, from math import pi. We'll talk about that in a future lesson. But suffice to say that that gives us a variable pi that has the value of pi in it, a float value. But we use the string method here to take that float value and create a string object from it. So you can see initially the variable pi has the type float, but then when we use the string function and pass it into the variable string object, we're able to print out string object and also look at its type, and it is in fact a string. We can perform some operations on strings as well. We can use 2 arithmetic operators on strings. There are 2 that we can't use. We can't do division of a string, and we can't subtract from a string with the minus sign operator. But we'll talk when we talk in the next video. When we talk about different methods, we'll talk about ways that we can remove things using some methods on strings, but we can't use those 2 operators. We can, however, use the plus sign operator and the multiplication operator. The plus sign operator lets us concatenate strings. That's essentially appending one string to another. And the multiplication operator lets us repeat a string any number of times. So there's some examples here you can run through of concatenating strings. Here we've created 2 strings, string 1 and string 2. String 1 has hello, string 2 world, and we can append them together along with a blank space in between with the plus sign operator. This is different from the result we get when we do addition of numeric variables. Of course, then the numeric values are added together, but with strings, the plus sign operator concatenates the strings. And as we saw before, we can put multiple strings together with the plus sign operator. If we want to repeat strings with the multiplication operator, we simply take the string variable that we're interested in, or the string itself, follow it with a multiplication symbol, and then the number of times that we'd like to see it multiplied. So here, if we take the string cu, comma, and a space, and we print that variable that we made up, string value, and then the multiplication symbol and the number 3, we get cu, cu, cu. Note that that multiplier needs to be an integer. We can't multiply a string by a float. We can't produce a result that has some fraction of the string when we do multiplication. If you try this cell, in cell 4, you can see again from the math library that we pulled in the value of pi, and if we use that value as a multiplier on a string, we get an error message. The error message tells us we can't multiply that type of sequence, a string, by a non-integer, right? A non-integer like a float. We also can we can mix and match. We can mix and match concatenation and multiplication. So here we've created 3 string objects. Object 1 says cu, string object 2, at the party, and string object 3, tonight, Richter. And Terminator fans will recognize that somewhat twisted quote at this point. where we've taken the first string object and we've added to a repetition of the second string object 3 times, and then concatenated the third string object on top of all that. Play around and practice with that, try different strings, try different operations. But remember PEMDAS when you do the sequence of operation. Let's talk about escape sequences as well. Escape sequences give us a way to include special characters in a string, special characters that are typically hidden from us. So I mentioned new line characters before, carriage returns. When we create a multi-line string, in a multi-line string that has more than one line, there are special characters, new line characters, at the end of every line. The new line character tells the computer to go to the next line. There's also a special character for tab that tells the computer to just tab forward some number of spaces, perhaps 8 spaces. If we want to include those special characters, in a string, we precede them with a backslash. A backslash inside a string, a backslash tells Python that there's an escape sequence following. A backslash and a lowercase n tells Python to put a new line character there. A backslash and a lowercase t tells Python to tab. And we can even include a backslash in our string by following a backslash with another backslash. We can use these escape sequences as well as another way to insert either apostrophes or double quotes inside a string. So even if we've delimited a string with double quotes, we can include a double quote inside it by marking the double quote as an escape sequence with a backslash before it. There's some examples here that you can use to play around with it. Here's one where we're putting the single quote escape character into the string, so we get a string that tells us this isn't a good example, right? Although in the assignment we have a backslash before that apostrophe that we want to include. And note that that particular string is delimited with single quotes, yet we were able to include a single quote in the middle of it. Here's an example where we put a backslash in our string. Here's an example where we've put some double quotes inside a string without using escape characters. And here we're putting some single quotes inside a string delimited with single quotes by using an escape character. We can do the same with double quotes. If you'd like here to play around a little bit, here's an example that does a number of things at once, putting tab characters and backslash characters and double quotes inside these strings in print statements. The output, when you play this cell, the output will look like this grayed out area at the bottom. You can play with that. Let's talk about formatting strings. And this is an area, formatting strings is an area where there have been some changes since release 3.6 of Python. There are 3 ways that we could format strings, that we could use the content of variables to change the string that we're assigning or we're printing. We can include values from variables inside strings. This gives us a lot of flexibility. 3 ways we'll talk about are F strings or using the format method. And then there's an appendix at the bottom of this notebook. There's an appendix that talks about using the % symbol to embed values. This is an older technique for formatting strings in Python. I don't recommend that you use it, but you may want to learn a little bit about it in case you run into it in some older programs. F strings are generally preferred because they're easier to read, they're more efficient. It'll make the maintenance of any code that you write more efficient for those who follow you. So how do F strings work? Well, let's take an example. An F string basically is a string, whether we've delimited it with single or double quotes or even a doc string. It's a string that we just precede with the letter F. No space between the F and the first quote delimiting the string, just F, and then whatever the string delimiter is that we're using. In this case, in the example here, we're using a double quote. If we set up an F string, that gives us the ability to insert pairs of curly braces that enclose variable names that we'll use to embed values. You can think of them as a kind of a template, right? A way of printing some text as a template where there's a variable component to the text. In this example, we've created two variables, one called name and one called age. And we've made an F string that includes pairs of curly braces. One pair includes a reference to the variable name, and one pair includes a reference to the variable age. And if we play this bit of code, you see that the values that we had for those two variables get embedded into the string when it's printed. Here's another example that runs through some arithmetic calculations. We can not only put variable names inside the curly braces in an F string, but we can put whole expressions there. We can put entire expressions there. The expression will be evaluated. The result of the expression is what will be embedded in the string. So if you have a look at this block of code and play it, you can see we've only created two variables, A and B. We assign the integer value 4 to A and the integer value 3 to B. And in our print statements, of course, we're able to embed the values 4 and 3 by referring to those variable names A and B. But we're also able to do some calculations, and the results of the calculations are embedded in the strings as well. That's where we get the 7, the 1, the 12, the 1.3, and the rest of the results in the printouts. This is really handy. Another way to do it is the format method. The format method, we don't precede the string with the letter F, but we add the format method with dot notation following the string. And we could do that on a string that we've just delimited with pairs of quotes, or we could do that on a variable that we've created that's a string. We use the format method, and we pass to the format method arguments, any number of arguments that we like, but the number of arguments that we pass needs to match the number of open and closed curly braces that we've put inside the string. In this case, we've put two pairs of curly braces in the string. We've created two variables, name and age, and when we invoke the format method, we pass both those variables as arguments to the format method, name and age. What the format method does is it goes into the string, looks for those pairs of curly braces, and in order from left to right, it takes the values of the arguments that it's received and puts an argument value in where it sees a pair of curly braces. So in this case, if we've got a variable variable name that has the string Bob and a variable age that has the value 25, and we pass both those as arguments to the format method on a string that has two pairs of curly braces, the value of the variable name will be embedded in the place where the first pair of curly braces was found, and the value of the variable age will be embedded in the place where the second pair of curly braces was found. Note that these variables don't have to be string variables. This is true with F strings as well. They don't have to be strings. That the format method and the F string that we looked at earlier, they'll take the value that a variable has, and they'll make sure to put it into a string format before embedding it in the string. One thing to be careful about, though, with the format method is the sequence of providing the arguments really matters. So if we flip those two variables around in that bit of code that we wrote before, we get this kind of odd result. My name is 25 and I am Bob years old. So you can see why you've got to be careful to avoid confusing argument sequences when you're using the format method. There's a greater risk of error. F strings are preferred. The method, the older method that's described in the appendix is even more cumbersome, and we're not going to go over it here. But again, I'd like to stress the point that as much as you can, you want to get familiar with using F strings and try to get in the habit of using F strings. So I mentioned strings as a sequence of characters that we can look at each element in a string as a character. And we have an example of code here that unpacks a string for us. If we assign the string Python, capital Python, to a variable called word, we can use word in an assignment to 6 different variables, A, B, C, D, E, and F. And essentially, Python will iterate through the elements of that string variable word. Those 6 elements are the 6 letters, P, Y, T, H, O, and N. And in making assignments to the 6 variables, A, B, C, D, E, and F, Python's essentially iterating through the characters or the elements of the string variable and assigning a value to each of those variables. So when we do that, we get essentially for each of the variables, we get 1 letter out of the string or the word Python. Because Python treats strings as a sequence of elements, we can reference the characters in that sequence. So to use our example of a string that has Python as the characters in it, we would reference those characters by their index position. We start indexing at what's called the offset from the first value. In the case of the string Python, the capital letter P is the first value, so its offset position is 0. And then we just increase by 1. The Y is at index position 2, the T at index position, the Y is at index position 1, the T at index position 2, etc., up to the final letter, the 6th letter in the string, N, is at index position 5. We always have 1 less index position than we have length of a string because we start counting at 0. We don't start counting at 1. There are a number of exercises you can go through here to play around with taking that string Python, assigning it to a variable called word, and then referring to specific elements within that string variable. Remember, the index position 0 is the very first element or the first character in the string. Of course, we'd get the letter capital P here when we go to print the value at index position 0. One note here before we go too far, when you're referring to index positions in a string, you use a pair of square brackets around the index number. So we referred to the variable word that we created, and then we immediately followed word with a pair of square brackets, no space in between, just a pair of square brackets. And within the square brackets, if we put the index number 0, we get that letter P. If we put the value 1 for the index, we get that letter Y. And if we put the value 5, we get that final letter N. We can also use negative index values. Basically, negative index values start counting from the end of the string. And in this case, the last character is character -1. We don't start counting at -0, we start counting at -1. So that same N that we saw in index position 5, that's also at index position -1 if we were to count from the back of the string. If we want the second to last character, we can put a -2 and get the O before the N. If we want to take the very first character of those the 6 characters in that string, we would ask for index position -6. A little block of code here that you can use to play around with trying different values. You might want to make some changes to this code in your version of the notebook and play around with it and see what results you get. And likewise, there's another block of code here that you can use to play around with negative indexing. So we can use index values to pick and choose any individual character in a string, but we can also pull out substrings or slices within a string. So to get a slice of a string, we use a colon between the starting position and where we'd like to end. If we have a variable that we create called word using that string Python as the value for a string variable word, if we wanted to refer to the first 2 characters in that string, the first character, of course, is at index position 0. So again, in square brackets, we can reference index position 0, follow that with a colon, and then after the colon, we don't put the index position of the final character we're interested in, but rather we say the value that we want to go up to, but not including. Now, it sounds a little obtuse at first, but if you get used to it, it's almost a handy way of being able to remember the number of characters you want. In our case, we want 2 characters. We're starting at index position 0 and follow that with a colon and then the number 2. We can think of that as starting at 0 and going up to, but not including 2. But also, we might mentally think of that as, well, we want 2 characters here. We want to start at 0 and go for 2 characters. So we can print we can print those out, right? So that gives us the values P and Y. We don't have to start at the very first element in the string. We can start at any index position we like, and we can go up to and including any other. If we want, we can leave the second value blank and just leave a colon there. We leave a colon there, it tells Python that we want to go from whatever starting index position we specified to the end. So if we want to go from I'm sorry, Colab likes to get in the way. It likes to be too helpful. So in this case, we've said let's start at index position 2. That's the 3rd character. That's the T in Python, and go all the way to the end. If we don't specify a starting index position, then in the notation that we're using for a slice, if we just start with a colon, then we basically start at the beginning. It's the same as saying start at 0. And if we count backwards using negative references, then we'll start at the position that many spaces from the length of the string. In this case, we've said go back 3 spaces from the end. That's the letter H in Python. We followed that with a colon and nothing after the colon. So we basically said begin 3 spaces from the end of the string and go until the end of the string. And of course, we can put a value for that second value and say that we want to go, say, from 3 spaces from the back of the string up to, but not including the last character in the string. So there's some more examples here that you can play around with. That you can make some changes here. Perhaps even instead of using Python as the string that you store in Word, put some other string there. One word of caution, though, when you're referencing index positions in a string, you've got to use index positions that really exist in the string. So if the length of the string is 6 characters, like we have with the word Python, the highest index position is 5. You'll get an error message if you reference index position 6 or higher. We can use this. We can use this slicing reference to flip the string around. Just as a colon could tell us to start at the beginning or the end, we can use a colon followed by a colon to say start at the beginning, go to the end, and then we follow that with a third value, which is the step. By default, the step is 1, right? We step from one character to another or from one element to another. But if we put a -1 as the step, we'll be telling Python to go backwards. And if we use the string hello world in an assignment to a variable greeting, and then we use the indexing notation to say start at the beginning, go to the end, and step by -1. That's basically going to go backwards through the string. Similarly, we could use the step to go more than one element at a time. So here we're back to assigning the string Python to a variable word, and we've told with the indexing notation, we've told Python we'd like to start at the first element in word. We want to go up to, but not including the 6th element in word. So that'll take us to the end of word, to the fifth index position. And we want to step by 2. So instead of the default step of 1, we're going to basically take every other element. We'll take the P, skip the Y. See if we can get Colab out of the way. Take the P, skip the Y, take the T, skip the H, take the O, and then in the process of skipping the end, we are at the end of the string. If you'd like, this is a good point to perhaps pause the video and practice a little bit with some of the things that we've done. Also, a short exercise, if you take that string information and data management and you assign it to some variable in Python, see if you can use index references to print just the word information by using the indexing and slicing. And then try to print the word data by using a negative indexing or slicing approach. You can work on that exercise. When you're done with that, we're going to take a break. We'll stop this video, and I'll join you in part 2, where we get into string methods.